All right, if you've ever dipped your toes into chemical reactions, you've probably bumped into two words that sound super similar but are totally different: order and molecularity. They both try to tell us how a reaction happens, but, and this is the key, they come at it from completely different angles. So today, yeah, we're going to crack the code on this one.
So what is the real difference? I mean, really. Let's get right into it and break it all down. And we're going to start with order.
Okay, first up is order. And to really get what order is all about, we've got to talk about something called the rate law. You can think of it as the mathematical recipe for a reaction. It's the formula that tells us exactly how fast things are going to cook.
Now, the textbook definition is pretty math-heavy. A rate law just shows how the speed of a reaction depends on how much stuff, the concentration you have. The order is just the sum of the exponents, the little numbers on top of those concentration terms. But a better way to think about it, it's like a sensitivity score. It tells you exactly how much the reaction speed is going to jump up or slow down if you decide to dump in more of a reactant.
And this is probably the single most important thing to remember about order. You absolutely cannot figure it out just by staring at the balanced chemical equation on a piece of paper. Nope. You've got to get in the lab, get your hands dirty. It's a purely experimental thing. It comes from running the reaction, measuring the results, and looking at the data. It's all about what actually happens, not what you think should happen.
All right, so that's order. Now let's switch gears to molecularity. If order is what we see from the lab bench, molecularity is our view from the super tiny microscopic level. It's less about the big picture reaction and more about, well, counting the individual players, the molecules, that are getting involved in one specific move.
And you know what? The definition here is way more intuitive. It's basically just a head count. How many molecules or atoms or ions physically smash into each other at the exact same time to make something happen. If it's just one molecule doing its thing, we call that unimolecular. If two collide, bimolecular. See? It's just a simple count for one single step in the process.
And this really gets to the heart of the difference. Molecularity isn't talking about the whole entire reaction. It's only talking about the individual elementary steps inside a proposed reaction mechanism. It's a theoretical concept. It's what chemists sketch out on paper, a possible sequence of events to try and explain what they're seeing in the lab. They then assign a molecularity to each of those theoretical steps.
Okay, so we've defined both of them. Let's put them side by side now so the differences really sink in. This right here shows you the fundamental split. Order is all about the overall reaction, the big picture, and it comes from that experimental rate law we talked about. Molecularity, though, that's all about a single, tiny elementary step within the reaction, and it comes from just counting the particles we theorize are bumping into each other in that one moment. This table just lays it all out perfectly. Look at the nature row. That's the big one we've been talking about. Experimental versus theoretical. Real world versus on paper. Then look at values. This is another huge giveaway. Because order is calculated from real data. It can be a whole number, sure, but it can also be a fraction, or even zero. But molecularity? It's a count of actual things. It has to be a positive whole number. I mean, think about it. You can't have half a molecule show up to a collision, right?
So if you only remember one thing from all this, let it be this simple idea. It all comes down to the lab versus the theory.
Let's just hammer this home one last time, okay? Order is the real-world measurable effect you see in the lab. Molecularity is the theoretical story you write on paper to explain that observation. See the difference? What you see versus how you explain it. That is the absolute key. And that leaves us with one final thought to chew on. We've got one concept, order, that comes from hard, cold lab data, and another, molecularity, that comes from a theoretical model. So which one do you think is actually more useful for a chemist who needs to, get things done in the lab? While the theory is great for helping us understand the why behind it all, it's that experimental data from the order that lets us predict and control what's actually going to happen in the flask. And really, it's that dance between theory and real-world results that pushes all of chemistry forward.